it's kind of tricky. So um, basically, a 2860 kilogram car has a front profile of 1.92 meters wide and 1.4 meters high. What power must it have, or the engine more specifically, have to drive 26 meters per second? And like this is constant, so a steady 26 meters per second. But before reaching the reels, 31.8% of the power is lost. So basically, what we have to remember is in this case, you do not neglect air resistance, you do not neglect drag. So if you recall from like an earlier time, the formula for the force drag is equal to 1/4 times the area times velocity squared. So basically what you're trying to do is try to find the net power, so that so then you can find, or not, yeah, the net power, the total amount of power it must have. So to do that you have to find the net force. So, and also remember the force of friction is mg mu. So force drag and force friction are acting in the same direction, right? Because they're both resistive forces. Like when the car is moving this way, drag and friction are going to slow it down this way. So these would just, the main point is these are in the same direction. So what you can do is you can add those two up to get a net force. So going back to the equation, power equals force times velocity, we get the power for the car. So yeah, like this is actually pretty useful. Like you basically just use base times height to find the area here. Sorry for not mentioning that. So this is base times height. So then you can calculate the power of the car, but it's the power of the engine that we're trying to find. So 31.8% of the power is lost before reaching reels. So that means that the power of the car is 31.8% is yeah 31.8% less than the power of the engine. So that'd be 0.682 times P engine because think about it, like when you turn on a car, the engine keeps going and going and going, and then the power is going to be dissipated and such from the car when the engine keeps going and going and going. Like, you know how cars run out of battery? That's because you keep losing more and more power from the engine, or you keep losing more when the engine's going on. You lose more and more power in the car. So what you can do is you can divide by 0.682 on both sides. and then you get an answer of 39,183 watts. And if we want to convert that to horsepower, we could just do 39,183 watts times 1 HP over 746, and that's equal to around 52.5 HP. So yeah, thank you for watching. If you have any questions, please comment down below, and I'll see you guys next time.